They told us the edge of the solar system was a quiet, empty void. But Voyager proved them wrong. When it crossed into the unknown, it found something we never expected: a chaotic, mysterious region where solar winds clash with forces from deep space. Strange bursts of plasma waves, twisted magnetic fields, and a faint, eerie hum coming from interstellar space. These discoveries aren't just shocking, they're rewriting everything we thought we knew about our universe. But here's the real question. If the edge of the solar system is this unpredictable, what lies beyond? And why are scientists calling it one of the most important discoveries in space exploration? Buckle up, because what you're about to learn about Voyager's journey could change our place in the cosmos forever. In 1977, NASA launched the Voyager missions, two spacecraft designed to explore the unknown. But what started as a quest to study the outer planets turned into something far more extraordinary. Decades later, these robotic explorers ventured beyond the farthest reaches of the solar system into a realm no human-made object had ever entered before. What they found there shattered our understanding of the cosmos. Imagine a place where the sun's influence ends and the cold, uncharted expanse of interstellar space begins. This isn't just a boundary, it's a turbulent frontier, alive with forces we barely comprehend. Voyager's instruments recorded phenomena so strange, so unexpected, that even scientists were left questioning the laws of physics. A mysterious hum, an invisible shield riddled with holes, and magnetic fields twisted like knots in a string. What's really out there? What did Voyager detect on the very edge of the solar system? Could it hold clues to mysteries we haven't even dared to ask? This video will take you on a journey billions of miles from Earth to the edge of everything we know and beyond. Stay with us, because what you're about to discover will change the way you think about the universe, and maybe even your place in it. For decades, we've imagined the edge of the solar system as a simple boundary, a line where the sun's influence quietly fades and interstellar space takes over. But what if I told you it's nothing like that? What if this so-called edge isn't a line at all, but a stormy battleground, a place of chaos, turbulence, and forces that defy easy explanation? This is what Voyager uncovered when it reached the heliopause, a region unlike anything scientists had predicted. Here's the thing. The heliopause isn't just a boundary. It's a shock zone, where the sun's solar wind, an invisible stream of charged particles, slams into the interstellar medium, the vast ocean of radiation and particles between stars. And what happens there is anything but simple. Instead of fading smoothly, the sun's influence stretches, twists, and mingles with interstellar forces in ways that left scientists scratching their heads. But here's where it gets even stranger. When Voyager crossed this zone, it recorded data that upended everything we thought we knew. Temperatures were unexpectedly high, magnetic fields were tangled, and cosmic rays, high-energy particles from deep space, seemed to sneak through weak points in the sun's protective bubble. So what's really going on out there? Is this region a shield, a gate, or something far more complex? Think about it. What's keeping interstellar radiation from bombarding our solar system? Are there unknown forces shaping this boundary? Forces we haven't even imagined yet? And what does it mean for our understanding of the universe if this edge isn't just a boundary but a dynamic, ever-changing zone of cosmic interaction? Voyager's data also revealed a strange hum, a faint vibration coming from interstellar plasma. What's causing this eerie sound? Is it a clue about what lies beyond? Or is it the universe's way of reminding us how little we truly know? Could this hum hold the key to understanding the transition between our solar system and the rest of the galaxy? Here's another mystery. The magnetic field at the heliopause wasn't neat or predictable. Instead, it twisted in unexpected ways, hinting at complex interactions we can't yet explain. Why is the magnetic field behaving like this? Could it be that the sun's influence reaches farther into interstellar space than we thought? Or is interstellar space pushing back harder than we ever imagined? And then there's the heat. Scientists expected the heliopause to be cold. After all, it's on the outskirts of the sun's domain, far from its warming rays. But Voyager found temperatures in the millions of degrees. How is that even possible? Is it the result of violent clashes between particles from the sun and those from interstellar space? Or is there another energy source out there, one we've yet to discover? These questions don't just matter for understanding the heliopause. They matter for understanding the solar system itself. If this chaotic zone is the boundary of our home, what does that say about the safety of Earth and the other planets? Are we truly insulated from the raw forces of the galaxy? Or are we living in a fragile bubble that's constantly under siege? And perhaps the biggest question of all, what lies beyond this boundary? Voyager is now traveling through interstellar space, sending back glimpses of a realm no human-made object has ever explored before. But is this just the beginning? Could there be more boundaries, more layers of interaction between the sun and the galaxy, waiting to be uncovered? The edge of the solar system isn't just a place, it's a puzzle. And every piece of data Voyager sends back reveals just how little we truly understand. So what's out there? And how much are we still missing? Keep watching, because this is only the start of the story. The heliopause, often imagined as a distinct line dividing the solar system from interstellar space, is anything but simple. It's more like a chaotic borderland, a region where the sun's solar wind, a continuous stream of charged particles, crashes into the interstellar medium, a sea of cosmic radiation and particles that fills our galaxy. If the solar system were a giant ship, the heliopause would be its turbulent outer hull, constantly tested by the cosmic waves beyond. For decades, scientists theorized about what this region might look like. Would it be calm and predictable? Or would it resemble a cosmic storm? The Voyagers gave us the answers. When Voyager 1 crossed this boundary in 2012, it sent back data that stunned scientists. Instead of a smooth transition, the heliopause turned out to be an intense, dynamic zone. The sun's influence didn't just fade away at the edge, it collided and mingled with interstellar forces in complex and unexpected ways. Instruments aboard Voyager 1 detected bursts of plasma waves, intense vibrations in space that hinted at powerful interactions happening in this boundary region. But what caused these plasma waves? To understand this, we need to think about what happens when two massive forces collide. The solar wind, made of charged particles ejected by the sun, travels outward at incredible speeds, creating a protective bubble around the solar system called the heliosphere. However, as this solar wind reaches the edge of the heliosphere, it slams into the interstellar medium, creating a shock wave similar to what happens when ocean waves crash against a rocky shoreline. The result? Turbulence. These plasma waves, picked up by Voyager's instruments, were the cosmic echoes of this ongoing battle. They revealed that the heliopause isn't a clear boundary. Instead, it's a constantly shifting zone where particles from the sun and the galaxy clash and combine, creating bursts of energy and vibration. Then there's the solar wind itself. Voyager showed us that the sun's protective bubble, while impressive, is not impenetrable. The solar wind weakens as it travels outward, and by the time it reaches the heliopause, it's no longer strong enough to keep out high-energy cosmic rays from interstellar space. These rays, made of particles accelerated by events like supernova, penetrate the heliosphere, seeping into the solar system through gaps in the boundary. This finding was a game-changer. It revealed that our solar system isn't as isolated as we once believed. Instead, it's constantly interacting with the galaxy beyond. Voyager also uncovered something even stranger: the magnetic field at the edge of the solar system. Scientists expected the sun's magnetic field to fade smoothly into the interstellar field. But Voyager found that the boundary was chaotic, with twisted and tangled magnetic lines. These irregularities suggested that the sun's influence extends farther than we imagined, blending with the galaxy's magnetic forces in ways we don't yet fully understand. And then there's the question of temperature. One of the biggest surprises from Voyager's data was just how hot the heliopause is. Before the spacecraft crossed the boundary, scientists predicted it would be a cold, calm region. After all, the sun's heat diminishes with distance, and interstellar space is famously frigid. But Voyager found temperatures at the heliopause that defied logic, millions of degrees hotter than expected. This heat isn't from the sun, it's created by the collisions and shockwaves between solar and interstellar particles. It's like a cosmic friction zone, where energy from the two forces is released as heat. Voyager's discoveries didn't stop there. As the spacecraft ventured beyond the heliopause, it detected a faint, persistent hum, a constant vibration caused by interstellar plasma waves. This hum, though imperceptible to human ears, was a haunting reminder that space, even in its emptiest reaches, is never truly silent. It was a cosmic symphony, playing softly across the vastness of interstellar space. But perhaps the most fascinating part of Voyager's journey was what it revealed about our place in the galaxy. The heliopause isn't just a border. It's a shield, one that protects the solar system from some of the most dangerous forces in the universe. Without it, high-energy cosmic rays and interstellar radiation would bombard our planets, potentially making life as we know it impossible. Voyager's data gave us a new appreciation for the sun's role as a guardian of the solar system, even at distances where its light barely reaches. And yet, this protective shield is far from perfect. Voyager showed us that the heliopause is riddled with vulnerabilities. The sun's solar wind creates a barrier, but it's not an unbroken wall. Instead, it's filled with gaps and weak points, yet where cosmic rays can penetrate and reach the inner solar system. These findings have implications not just for our understanding of space, but for future exploration. If we one day send astronauts beyond the heliopause, they'll face a radiation environment far more intense than anything within the solar system. The data from Voyager also raised new questions. For instance, why is the heliopause so irregular? Why do some parts seem thicker and more resistant, while others are thin and easily penetrated? Scientists now believe this may be due to variations in the interstellar medium. Just as ocean currents vary in strength and direction, so too does the flow of particles and forces in interstellar space. Voyager's findings suggest that the boundary of our solar system is constantly shaped by these external influences, making it a living, ever-changing frontier. In many ways, the heliopause is like a weather system on a galactic scale. It has currents, storms, and even seasons, dictated by the interactions between the sun and the interstellar medium. Understanding these dynamics is critical, not just for science, but for the future of space exploration. If we ever hope to send probes, or even people, beyond the solar system, we'll need to understand the challenges posed by this volatile region. Voyager's journey to the edge of the solar system wasn't just a scientific milestone. It was a profound reminder of the vastness and complexity of the universe. The heliopause, once thought to be a simple boundary, turned out to be a dynamic, turbulent zone filled with mysteries we're only beginning to unravel. And as Voyager continues its journey into interstellar space, it carries with it the hopes and dreams of a species eager to understand its place in the cosmos. For decades, scientists envisioned the solar wind, a continuous stream of charged particles from the sun, as a protective force, shielding the solar system from the harshness of interstellar space. This region, called the heliosphere, acted like a cosmic bubble, encompassing all the planets and extending far beyond Pluto. The idea was simple. The solar wind would form a strong, consistent barrier, blocking or deflecting harmful cosmic rays and interstellar particles. But what Voyager revealed shattered this tidy picture. As Voyager approached the heliopause, the boundary where the solar wind meets the interstellar medium, it uncovered a shield that was anything but uniform. Instead of a seamless wall, it resembled a patchwork quilt full of gaps and weaknesses. High-energy cosmic rays, tiny, incredibly fast particles originating from distant supernova explosions, weren't stopped entirely. They found pathways through the heliosphere's uneven protection, slipping into our solar system like water through a sieve. These cosmic rays are highly energetic and potentially harmful. On Earth, we're shielded by both our atmosphere and the planet's magnetic field. But in the vast expanse of space, such protection doesn't exist. Cosmic rays can damage spacecraft, disrupt sensitive instruments, and pose significant risks to astronauts. Understanding how these particles breach the heliosphere is crucial for future space exploration and protecting technology and human life in deep space. The heliopause isn't a static, impenetrable wall. Voyager's data showed that it's a chaotic and turbulent zone where solar wind particles crash into the interstellar medium. This collision creates shock waves, compressing and heating the plasma, which influences the structure of the barrier. At times, the solar wind strengthens, pushing the boundary outward. At other times, it weakens, allowing interstellar particles to press inward. This constant flux means that the heliosphere's ability to shield the solar system is always changing. One of the biggest surprises Voyager uncovered was the existence of magnetic fissures in the heliosphere. These gaps form where magnetic fields from the Sun and interstellar space interact in unexpected ways. Instead of forming a unified boundary, the magnetic fields twist, reconnect, and create openings that cosmic rays exploit. Think of it like this. Imagine trying to hold back a flood with a net. No matter how strong the net is, water will still seep through the holes. Similarly, these magnetic fissures allow cosmic rays to enter the heliosphere, slipping through where the solar wind's influence wanes. The Sun itself plays a major role in shaping the solar wind barrier. Every 11 years, the Sun goes through a solar cycle, alternating between periods of high and low activity. During solar maximum, when the Sun is most active, its magnetic field is stronger, and the solar wind intensifies, pushing the heliopause farther out. During solar minimum, the opposite happens. The heliosphere contracts, and the solar wind weakens, allowing more cosmic rays to penetrate the barrier. Voyager's journey coincided with a period of relatively low solar activity, meaning it observed the heliosphere at one of its most vulnerable states. This timing was both fortunate and revealing. It showed scientists how fragile this boundary can be under certain conditions, raising questions about how interstellar space influences our solar system during extended periods of solar quiet. Beyond the heliopause lies the interstellar medium, a vast expanse filled with charged particles, dust, and radiation that pervades the galaxy. While the solar wind tries to push outward, the interstellar medium pushes back. This cosmic tug-of-war creates an unstable frontier where particles from both sides mix. Voyager's instruments detected energetic particles that shouldn't have been there. Proof that the interstellar medium wasn't just sitting passively beyond the heliopause. Instead, it actively interacts with the solar wind, compressing and distorting the heliosphere. One of the most striking findings was the presence of cosmic ray foreshocks, areas where interstellar particles appear to bounce back and forth across the boundary, interacting with solar wind particles in unpredictable ways. These interactions generate turbulence and waves that ripple across the heliopause, adding yet another layer of complexity to this chaotic region. The implications of these findings extend far beyond academic curiosity. Understanding the solar wind barrier is critical for the future of space exploration. As humans venture deeper into space, to Mars, the Moon, and eventually beyond the heliosphere, cosmic rays will become a bigger concern. Without the heliosphere's partial shield, astronauts and spacecraft would be exposed to dangerously high levels of radiation. Even the technology we rely on here on Earth could be affected. Voyager's discoveries remind us that the heliosphere is not an unchanging protective bubble, but a dynamic and fragile frontier. If cosmic rays can penetrate the heliosphere during low solar activity, what might that mean for future periods of weakened solar wind? Could there be times when Earth itself is more vulnerable to interstellar radiation? Voyager's journey to the solar system's edge transformed our understanding of the heliosphere. It revealed a boundary far more complex and porous than we imagined, a place where the Sun's influence wanes but never fully disappears. It also showed us that interstellar space isn't a quiet void, but a bustling environment full of energetic particles and magnetic chaos. This isn't just about rewriting textbooks, it's about redefining how we see our place in the cosmos. The solar wind barrier isn't a simple line dividing us from them. It's a turbulent, ever-changing frontier that connects our solar system to the rest of the galaxy. And thanks to Voyager, we now have a glimpse of what lies beyond. The magnetic field mystery. Another shocking discovery Voyager uncovered at the edge of the solar system was the bizarre behavior of magnetic fields. Scientists had long believed that the Sun's magnetic field would gradually weaken and align smoothly with the interstellar medium as it extended outward. But Voyager revealed something completely different. When the spacecraft crossed the heliopause, it detected magnetic field lines that were anything but orderly. Instead of a neat, predictable transition, Voyager's instruments picked up a chaotic web of twisted, irregular magnetic patterns. It was as if two immense forces, the Sun's magnetic field and the galactic magnetic field, were wrestling for dominance. This chaotic environment isn't just a scientific curiosity. It's a battleground where solar particles and interstellar particles clash. Imagine a border zone where two vastly different territories collide, neither fully in control. The sun's magnetic influence doesn't simply end. It blends and warps as it meets the galaxy's own magnetic forces. But why does this happen? Scientists think it's due to the dynamic nature of the heliopause itself. The sun constantly emits streams of charged particles through its solar wind, and these particles carry the sun's magnetic field outward. Meanwhile, interstellar space isn't empty. It's filled with its own particles and magnetic influences. When these forces collide, they create turbulence that twists and distorts the magnetic fields into unpredictable patterns. Voyager's instruments also picked up surprising evidence of magnetic reconnection, a process where magnetic field lines break and reconnect, releasing enormous amounts of energy. This phenomenon has been observed near Earth and other planets, but seeing it at the edge of the solar system was unprecedented. It suggests that the heliopause isn't a static boundary. It's constantly shifting and crackling with energy. And then there's the question of scale. Voyager showed us that the sun's magnetic influence stretches much farther than we once thought. Even 18 billion kilometers from Earth, the sun's magnetic field is still interacting with interstellar forces, proving that our star's reach extends deep into the galaxy. This was a revelation. For decades, we imagined the heliopause as a sort of outer fence around the solar system, but Voyager revealed it's more like a tangled, energetic frontier. Adding to the mystery, Voyager's data indicated unexpected variations in the magnetic field's strength. Scientists predicted a gradual weakening as the spacecraft moved farther from the sun. Instead, the measurements fluctuated wildly. At some points, the magnetic field seemed stronger than anticipated, while at others, it dipped to almost nothing. This irregularity left researchers wondering, is the heliopause more active than we thought? Or is it influenced by unknown forces in interstellar space? And that brings us to another revelation: temperature. Most scientists assumed the heliopause would be cold, a quiet zone where the solar wind fizzled out and gave way to the chill of interstellar space. But Voyager's findings flipped this assumption on its head. Instead of a cold, tranquil environment, Voyager detected shockingly high temperatures. The heliopause turned out to be a hot spot of activity, with temperatures reaching millions of degrees. But here's the twist. This heat doesn't come from the sun. It's generated by the intense collisions between solar wind particles and interstellar particles. When these high-energy particles collide, they create shock waves, violent high-speed disruptions that heat the surrounding environment. These shock waves ripple through the heliopause, turning it into a turbulent, energetic zone rather than the peaceful boundary scientists once imagined. In fact, the heliopause is so dynamic that Voyager's instruments sometimes struggled to keep up. The spacecraft recorded bursts of plasma waves, low-frequency vibrations traveling through space. These waves are a direct result of the sun's magnetic field clashing with interstellar forces. What's even more intriguing is how this region may act as a filter. The chaotic magnetic environment likely plays a role in shaping what enters and exits the solar system. High-energy cosmic rays from interstellar space, for example, must navigate this tangled magnetic web to reach the inner solar system. Voyager's data suggests that some of these rays are deflected or slowed down, while others slip through the cracks. This discovery has profound implications. It means the heliopause isn't just a passive boundary. It's an active shield that protects the planets, including Earth, from some of the galaxy's most harmful radiation. Without it, life on Earth as we know it might not be possible. But despite all these breakthroughs, heliopause remains one of the least understood regions in our solar system. Voyager's journey has given us tantalizing clues, but many questions remain unanswered. For instance, how does the heliopause change over time? Does it expand and contract as the sun's activity fluctuates? And what does this mean for the particles and magnetic fields it interacts with? One thing is certain: Voyager's discoveries have completely redefined our understanding of the solar system's edge. The heliopause isn't a simple line or a peaceful transition. It's a dynamic, energetic frontier that holds the key to understanding how our solar system interacts with the galaxy. as Voyager continues its journey into interstellar space, it's still sending back data, helping us piece together this cosmic puzzle. Every bit of information it collects adds to our knowledge of this mysterious boundary and of the universe itself. Cosmic ray detection? As Voyager 1 and 2 ventured toward the edge of the solar system, scientists were eager to gather data that would reveal the true nature of space beyond the heliopause. One of the most fascinating discoveries Voyager made in this uncharted territory was the dramatic increase in cosmic rays, high-energy particles traveling at near the speed of light. These cosmic rays, originating from beyond our solar system, provide an invaluable window into the environment of interstellar space, a place we've only just begun to understand. Now you might be wondering, what exactly are cosmic rays, and why do they matter to our understanding of space? Cosmic rays are not rays in the traditional sense, but rather incredibly energetic particles, mostly protons and atomic nuclei. These particles are generated by sources far outside the solar system, such as exploding stars, supernovae, and even distant galaxies. When these particles travel through space, they encounter the vast emptiness between stars and planets, hurtling across light years with incredible energy. These high-energy particles can have significant impacts on everything they collide with, including spacecraft and even life on Earth. Before Voyager's journey into the outer reaches of our solar system, scientists had a limited understanding of how these cosmic rays behave beyond the Sun's protective bubble, the heliosphere. The prevailing theory was that the heliosphere, a vast magnetic shield created by the Sun's solar wind, effectively kept most of these cosmic rays at bay. After all, the solar wind is composed of charged particles that move outward from the Sun, forming a kind of protective barrier around the entire solar system. But as Voyager crossed into the uncharted territory beyond the heliopause, the boundary where the solar wind's influence begins to fade, the unexpected happened. The spacecraft's instruments began picking up a marked increase in cosmic rays. The sharp spike in cosmic rays was a clear sign that Voyager had crossed a crucial threshold. It wasn't just about escaping the Sun's influence. The transition into interstellar space revealed an environment that was far more hostile and unpredictable than scientists had imagined. The space beyond the heliopause isn't a quiet void. It's full of high-energy particles, many of which pose potential dangers to future space exploration. But the cosmic rays Voyager detected weren't just a random occurrence. Their behavior, along with the dramatic increase in concentration, revealed something even more significant. The heliosphere's protective bubble isn't as impenetrable as scientists once thought. The Sun's solar wind does offer protection, but it has its weaknesses. Small, high-energy cosmic particles from interstellar space can still penetrate this boundary, infiltrating the solar system in ways that challenge our long-standing assumptions about space's protective shield. This revelation has profound implications for our understanding of the dangers future spacecraft may face as they journey beyond our solar system. If these cosmic rays can penetrate the solar wind's protective shield with such intensity, future interstellar missions, perhaps even missions designed to explore other star systems, will need to be equipped to withstand and mitigate the potential damage caused by these particles. The sheer power of cosmic rays could interfere with spacecraft electronics, disrupt communications, and even pose a risk to the health of astronauts traveling beyond the reach of Earth's magnetic field. Moreover, this increase in cosmic rays challenges our understanding of the galactic environment that spacecraft will encounter on their journeys into deep space. As Voyager continues its path into interstellar space, we're learning more about the intensity and frequency of these cosmic rays, providing invaluable data to prepare for long-term space travel. This information isn't just theoretical. It's critical for ensuring the safety and success of future space exploration missions. Understanding the behavior of cosmic rays could determine how we build spacecraft, protect vital equipment, and safeguard human life in the unforgiving conditions of deep space. What Voyager discovered at the edge of the solar system is a harsh reminder of the challenges awaiting humanity as we venture further into the stars. The dramatic increase in cosmic rays doesn't just highlight the risks, but it also emphasizes the importance of further study. As our spacecraft continue to explore deeper into the cosmos, understanding the true nature of these high-energy particles will be essential in shaping the future of space exploration. So, as we marvel at Voyager's achievements, we must remember that its discoveries go far beyond the technical feats of spacecraft engineering. They offer us an intimate glimpse into the chaotic, powerful, and mysterious forces that exist in the vastness of space. And while Voyager has crossed the heliopause and ventured into interstellar space, its findings about cosmic rays and the true nature of our solar system's boundary are just the beginning. These revelations are not just reshaping our understanding of the universe. They are laying the foundation for future exploration and helping us prepare for the unknown. The journey that began with a single spacecraft in 1977 continues today, not only uncovering the secrets of our solar system's edge, but also charting a course for humanity's future among the stars. Cosmic rays are just one piece of the puzzle, and as we continue to study them, we'll gain even deeper insights into the dangers and mysteries that await in the vast expanse of interstellar space. The interstellar wind effect. As Voyager 1 crossed the boundary of our solar system, the heliopause, it encountered a previously unknown phenomenon that scientists hadn't fully anticipated: interstellar wind. Unlike the solar wind, which originates from the sun and is relatively predictable, interstellar wind is a stream of charged particles blown from the rest of the galaxy. The discovery of this wind fundamentally changed our understanding of the environment beyond the solar system. To appreciate the full magnitude of this finding, we must first understand the unique role the heliopause plays in shaping the interactions between the sun and the surrounding interstellar medium. What exactly is interstellar wind? The term interstellar wind refers to the continuous flow of charged particles, primarily hydrogen atoms, but also heavier ions like helium and trace elements that move throughout the vast expanses of space. These particles travel at incredible speeds, often exceeding 200 kilometers per second, and have been ejected by stars throughout our galaxy. This wind is present throughout interstellar space, constantly moving through the Milky Way and interacting with everything it touches. Now, you might wonder, how is this different from the solar wind? Well, the solar wind is a stream of charged particles, predominantly electrons and protons, that are emitted by the sun. The solar wind forms a protective bubble around the solar system known as the heliosphere. It extends far beyond the planets and reaches out to the edge of the solar system, creating a region where the sun's influence dominates. Beyond this region lies the vast expanse of interstellar space, where the solar wind no longer reigns supreme, and the interstellar wind begins to take control. But here's the shocking part. As Voyager 1 journeyed through the heliopause into the interstellar medium, it wasn't just passing from one empty space to another. The boundary between the solar wind and interstellar wind wasn't clean, sharp, or simple. Instead, it was a zone of complex interaction, where the interstellar wind and the solar wind collided in ways scientists hadn't expected. How interstellar wind affects the solar system's bubble. The interaction between the solar wind and the interstellar wind has profound implications for the structure and behavior of the heliosphere. The heliosphere, as we now understand, isn't just a simple bubble of solar particles. It's a dynamic, ever-changing region shaped by the competing forces of the sun's solar wind and the interstellar wind. When Voyager crossed the boundary into interstellar space, it discovered that the solar wind didn't just stop abruptly. Instead, the solar wind was still interacting with the interstellar wind, creating a complex mixture of forces that scientists couldn't have predicted. Imagine a large, invisible bubble surrounding the Earth, protecting us from harmful cosmic rays and high-energy particles from outside our solar system. This bubble, the heliosphere, serves as a shield for our planets. But at the outer edges of this bubble, things aren't as straightforward as we thought. As the interstellar wind pushes against the solar wind, it creates turbulence and instability in the boundary. This results in what scientists call the termination shock, a region where the speed of the solar wind decreases abruptly, creating a series of shock waves. The interaction of these shock waves with the interstellar wind has been compared to the ripples created when two bodies of water collide, an ongoing, complex dance of forces that continues to shape the structure of our solar system's protective shield. Voyager 1's unanticipated discovery. When Voyager 1 crossed into the interstellar medium in 2012, the spacecraft's instruments began to pick up surprising readings that scientists weren't prepared for. Among the most significant discoveries was the subtle yet persistent effect of the interstellar wind on the spacecraft's trajectory. Voyager's instruments detected slight changes in the spacecraft's velocity and direction, a direct result of the interaction between the solar and interstellar winds. These changes, while subtle, are a testament to the power of the interstellar wind. They provided scientists with evidence that this wind has a more significant impact on the solar system's structure than previously thought. As Voyager drifted farther from the Sun, it began to feel the full force of the interstellar wind, with its subtle but constant push and pull, altering the spacecraft's path. These forces were unanticipated by scientists who had assumed the boundary between the solar wind and the interstellar medium would be more predictable and orderly. The interactions that shape our understanding of galactic forces. The discovery of interstellar wind has forced scientists to rethink how galactic forces interact. While the Sun's solar wind has long been understood as a dominant force in shaping the environment of our solar system, interstellar wind is now recognized as a critical player in this cosmic tug-of-war. This interstellar wind is not merely a passive stream of particles. It is actively shaping the outer boundaries of our solar system and influencing the behavior of the heliosphere. For years, scientists have grappled with questions about the nature of space beyond the solar system. They wondered if it was truly empty, or if other forces were at work. Voyager's detection of interstellar wind revealed that space is anything but empty. It is filled with charged particles, plasma, and radiation, all moving in complex patterns. The influence of the interstellar wind has become a key factor in understanding the dynamics of this region, and it's reshaping our view of how stars, planetary systems, and even galaxies evolve. Why does this matter for space exploration? The implications of the interstellar wind go far beyond the theoretical. Voyager's discoveries have the potential to change the way we think about future space exploration. If interstellar wind is this powerful and this unpredictable at the edge of our solar system, what does it mean for missions that aim to venture farther into the galaxy? As we send more spacecraft beyond the solar system, they will undoubtedly encounter the full force of the interstellar wind. Understanding how this wind interacts with the heliosphere is crucial for predicting how these spacecraft will behave and what challenges they will face. Will interstellar wind affect their trajectory? How will it influence their instruments and communication systems? These are questions that scientists must answer before sending out missions that aim to explore the stars and beyond. Furthermore, the study of interstellar wind has implications for our understanding of the broader galactic environment. The behavior of interstellar wind at the edge of the solar system provides us with a window into the larger forces at play in the galaxy. It offers a glimpse into the nature of the interstellar medium, the stuff that fills the space between stars, and helps us understand how it interacts with the Sun and other stars. The future of space exploration and the interstellar wind. Voyager's discovery of interstellar wind is just the beginning. As we continue to explore the boundaries of our solar system and beyond, we will undoubtedly encounter even more surprises. The data collected by Voyager 1 and Voyager 2 is invaluable, providing a treasure trove of information about the forces at play in the vast reaches of space. In the coming decades, we may see more spacecraft launched into interstellar space, equipped with instruments designed to study the properties of interstellar wind in greater detail. The implications of this research could help us design better spacecraft, protect them from cosmic radiation, and understand how our solar system fits into the larger galactic ecosystem. The study of interstellar wind may even help us answer some of the most fundamental questions about the nature of the universe itself. As we look to the future, the discoveries made by Voyager are laying the groundwork for the next era of space exploration. By better understanding the forces that shape our solar system and the broader galaxy, we can gain a deeper understanding of our place in the universe and the challenges we'll face as we venture farther into the stars. Conclusion: the power of interstellar wind of the solar system's boundaries, but also opened up new questions about the very nature of space itself. As we continue to explore the cosmos, the lessons learned from Voyager's encounter with interstellar wind will guide our path. We may have uncovered a small piece of the puzzle, but the mysteries of interstellar space are far from solved. What Voyager has shown us is that the universe is full of surprises, and the interstellar wind is just one of the many forces that shape the galaxy. As we continue our journey through space, who knows what other shocking discoveries await us beyond the solar system's edge. The boundary's role in protecting life on Earth. The heliopause, a seemingly distant and abstract concept, is far more significant than many people realize. This boundary zone at the edge of our solar system is not just a theoretical line drawn on a map of space. It plays a vital role in protecting life on Earth from dangerous cosmic threats. This protective zone is shaped by the solar wind, a stream of charged particles emitted by the sun. The solar wind acts as a cosmic shield, creating a buffer between our planet and the harsh, radiation-filled environment of interstellar space. Without it, the Earth would be vulnerable to cosmic radiation and other high-energy particles that could have detrimental effects on life. The solar wind extends far beyond the orbit of Pluto, forming what we know as the heliosphere. It's this vast bubble of charged particles that envelops the entire solar system, protecting the planets, moons, and even comets within it from the dangers lurking beyond. In this sense, the solar wind is like an invisible, yet incredibly powerful force field, keeping Earth and the rest of the solar system safe from cosmic radiation and interstellar winds that could otherwise strip away our planet's atmosphere or even make life impossible. However, as the Voyager spacecraft ventured beyond the heliopause and into interstellar space, scientists were forced to reassess their understanding of this protective bubble. What they discovered was both surprising and unsettling. The solar wind does not form a perfect, smooth barrier around the solar system. Instead, it is riddled with gaps and irregularities. At the boundary of the heliopause, the solar wind interacts with the interstellar medium, a region filled with cosmic radiation and high-energy particles from beyond our solar system. The energy from these particles does not simply dissipate or fade away at the edge of the solar system, but instead, it blends with the solar wind, creating a more chaotic and unpredictable boundary zone. This unexpected complexity challenges our previous understanding of how the solar wind behaves and, by extension, the protection it offers to our planet. Voyager's data showed that, instead of a clear-cut solid barrier, the solar wind forms a porous shield, a sort of cosmic Swiss cheese. This makes sense given the turbulent nature of space at the boundary, where solar particles collide with the interstellar medium, creating turbulent shock waves and complex patterns of magnetic energy. These irregularities suggest that cosmic rays from outside our solar system can penetrate the heliosphere with far more ease than we had imagined. If these high-energy particles were to breach the heliosphere unchecked, they could pose a significant threat to life on Earth. The particles of interstellar space, including cosmic rays, contain vast amounts of energy. Cosmic rays are composed of high-energy protons and atomic nuclei, and when they strike the Earth's atmosphere, they can trigger reactions that produce harmful radiation. This radiation could potentially affect our planet's atmosphere, lead to increased rates of cancer and other health problems, and disrupt communications and satellite systems. Moreover, the exposure to cosmic radiation could lead to more severe effects for astronauts or spacecraft venturing beyond Earth's protective shield. This is why understanding how the heliopause and solar wind interact with the interstellar medium is so critical, not just for our exploration of space, but for protecting Earth from external cosmic threats. Voyager's findings have helped scientists realize just how vulnerable we could be if this solar wind shield were to weaken or be breached in the future. While Earth's magnetic field offers some protection against solar radiation, the heliosphere's role in safeguarding us from the more intense cosmic radiation from deep space is just as important. Without the sun's influence extending this far, life on Earth would face much higher levels of radiation, which could potentially harm living organisms or disrupt the planet's delicate ecosystems. The constant bombardment of cosmic radiation could even lead to long-term climate changes or alterations in the ozone layer, further threatening life on Earth. But the story doesn't end there. The heliopause also plays a significant role in regulating the flow of high-energy particles. These particles can influence everything from Earth's magnetic field to the climate. Understanding how the solar wind interacts with these particles beyond the heliopause is crucial in predicting potential future events that could alter our environment. The fact that the heliosphere is not a uniform, consistent shield means that solar activity, such as solar flares or coronal mass ejections, can have a direct impact on the strength and stability of this protective bubble. If there were ever an extreme solar event, such as a massive solar flare or coronal mass ejection, it could disrupt the solar wind and damage the heliosphere's ability to protect Earth from cosmic radiation. For example, if a massive solar flare were to strike Earth without the protection of the solar wind, it could lead to catastrophic consequences. Solar flares have the potential to damage satellites, disrupt communication systems, and even affect power grids on Earth. These high-energy events would become far more dangerous without the protective influence of the heliosphere. And the possibility of such events growing more frequent or intense is an ongoing concern for space weather scientists. As our technology continues to improve, we are gaining a more detailed understanding of the solar wind and the heliopause, but there's still much to learn. One area of particular interest to scientists is the way cosmic rays interact with the solar wind, and how these interactions might change over time. For instance, the heliosphere is not a permanent fixture. It's influenced by the sun's activity, which changes throughout its 11-year solar cycle. During periods of high solar activity, the solar wind is stronger, expanding the protective bubble and pushing cosmic radiation further away. In contrast, during periods of low solar activity, the solar wind weakens, allowing more cosmic rays to penetrate the heliosphere. Understanding these cycles and how they affect the Earth's protection is crucial as we move forward. If solar activity were to suddenly decrease, leaving the Earth exposed to increased cosmic radiation, we would need to know how to mitigate the risks and protect ourselves from the potential harm caused by these particles. One way we might protect ourselves is through advancements in space weather forecasting, which would give us the ability to predict solar flares or other high-energy events and prepare for their effects. In addition, scientists are also exploring ways to shield astronauts from the dangers of space radiation. As we venture further into space, future missions to Mars and beyond will face the challenge of surviving the harsh conditions of interstellar space. The radiation levels outside the protection of the heliosphere are much higher, and without proper shielding, astronauts could face serious health risks. Learning more about the heliosphere's role in regulating radiation and cosmic particles could help engineers develop better spacecraft protection systems, shielding both astronauts and sensitive equipment from radiation damage. Ultimately, the Voyager missions have revealed the heliopause to be much more than just a boundary between the solar system and interstellar space. It's a dynamic, complex region where the forces of the sun and the interstellar medium collide, creating a buffer zone that helps protect us from the harsh realities of deep space. However, Voyager's findings also remind us that the solar wind and its role in safeguarding life on Earth is not as simple or secure as we once believed. By continuing to study this region and how it interacts with the universe beyond, we can better understand the risks we face and take the necessary steps to protect life on Earth, both now and in the future. As we look to the stars and dream of exploring the farthest reaches of the solar system and beyond, understanding the role of the heliopause and the solar wind in keeping us safe becomes even more critical. Voyager's discoveries not only change how we view the outer limits of our solar system, but they also highlight the importance of these cosmic forces in ensuring the survival of life on Earth. Through ongoing research and exploration, we can continue to unravel the mysteries of space and learn how to navigate the ever-changing environment of our solar system. ensuring that we remain protected from the dangers of the cosmos. The hum of interstellar space. One of Voyager's most haunting discoveries is the faint, persistent hum it detected as it ventured beyond the heliopause. This isn't a sound we can hear with our ears. It's a vibration captured by Voyager's plasma wave instruments, a tool designed to measure the density of charged particles in its environment. These instruments recorded a series of low-frequency plasma oscillations, waves moving through the interstellar medium, and they revealed something extraordinary. The vast expanse of space beyond our solar system isn't silent at all. At first, scientists didn't fully understand what Voyager was detecting. Space had long been thought of as a vacuum, a place devoid of matter where silence would be absolute. But as Voyager moved deeper into interstellar space, the hum became a defining characteristic of its journey. These plasma waves aren't sound in the traditional sense. They're more like ripples in a pond, created by the interplay of particles and electromagnetic forces in the interstellar medium. What makes this discovery so incredible is the insight it gives us into the environment outside our solar bubble. The hum Voyager detected reflects the density of interstellar plasma, the charged gas that fills the space between stars. As Voyager drifted further, it recorded subtle variations in this hum, peaks and dips that correspond to the movement and interaction of interstellar forces. Here's the kicker. This hum isn't random. It's a constant, steady vibration, almost like a heartbeat of the galaxy. It's thought to come from the natural oscillations of electrons within the plasma, set in motion by cosmic rays and other energetic phenomena. For the first time, humanity had a way to listen to the structure and dynamics of interstellar space. But it wasn't just a scientific curiosity. The hum offered critical data about the density of the interstellar medium, a number scientists had only estimated until Voyager's journey. By analyzing these plasma waves, researchers discovered that the density of interstellar space is higher than previously thought, averaging about 0.1 particles per cubic centimeter. That might sound like almost nothing, but compared to the vacuum of the heliosphere, it's dense enough to create these eerie waves. Another fascinating aspect of this discovery is how it changes with Voyager's movement. As the spacecraft continues to drift further, it encounters patches of varying density. Some regions cause the hum to intensify, while others bring it down to a whisper. These fluctuations help map the unseen structure of interstellar space. Regions of calm and turbulence, shaped by events like distant supernova explosions or the slow drift of interstellar clouds. The hum also raised new questions. For instance, could this vibration be unique to Voyager's position in space, or is it a universal feature of the interstellar medium? And what might happen as other spacecraft, like future interstellar probes, travel through these same regions? Voyager's data has already set the stage for answering these questions, but much remains a mystery. Perhaps the most poetic aspect of this discovery is what it tells us about the nature of space itself. The hum is a reminder that even in the darkest, most remote parts of the universe, there is movement, there is energy, there is life of a different kind, not biological, but the life of particles and waves, of forces colliding and reshaping the cosmos. So if you could hear this hum, what would it sound like? Scientists believe it would resemble a low, constant vibration, almost like the droning background noise of a distant machine. A soft, unending sigh from the galaxy itself, echoing across billions of miles. Voyager's detection of this hum isn't just an eerie footnote in its journey, it's a critical piece of the puzzle. It tells us that the space between stars isn't empty or static. It's dynamic, full of motion, and governed by physical forces that are still waiting to be fully understood. Voyager has given us ears to listen to interstellar space, and in doing so, it has forever changed how we see the boundary between our solar system and the vast galaxy beyond. As Voyager continues its incredible journey into the vast unknown, the significance of its mission cannot be overstated. The heliopause, once thought of as just a boundary, is now recognized as a dynamic frontier, a battleground where the sun's influence meets the chaotic forces of the galaxy. This is no ordinary boundary. It's a place where two cosmic powers collide, shaping the very space that exists between stars. The data collected by Voyager as it approaches this boundary is rewriting the textbooks on our understanding of the solar system and beyond. The encounter between the solar wind, the outflow of charged particles from our sun, and the interstellar medium, the space dust and particles scattered throughout the galaxy, creates an intricate dance of forces. Here, the protective bubble that surrounds our solar system begins to weaken, and the raw power of the universe beyond makes its presence felt. This complex interaction not only teaches us about the solar system's outer limits, but also about the forces that shape every star system in the galaxy. Voyager's mission is more than just a scientific endeavor. It is a symbol of human curiosity, determination, and the relentless pursuit of knowledge. As it ventures deeper into the unknown, Voyager represents a beacon of hope and possibility. Its golden record, which carries a message to potential extraterrestrial life, serves as a reminder of the profound questions we seek to answer. Where do we come from? Are we alone in the universe? What lies beyond the stars? For decades, we've looked at the night sky, wondering about the mysteries of the cosmos. Now, thanks to the work of Voyager and the incredible team of scientists and engineers who have made this journey possible, we are closer than ever to understanding not just the limits of our solar system, but the broader nature of our universe. Voyager has transformed our perception of the solar system from a static, well-defined entity to a dynamic, ever-evolving part of a much larger cosmic ecosystem. The data Voyager sends back provides more than just answers. It inspires new questions. What other phenomena might lie at the boundaries of our solar system? How might the interactions between the sun and the galaxy shape the future of our own star? And perhaps most importantly, how will this information continue to influence the next generation of explorers, scientists, and dreamers who will take humanity's quest for knowledge even further? As we continue to watch Voyager's progress, we can't help but feel a sense of awe and excitement. We are witnessing the unfolding of a new chapter in humanity's quest for understanding. This journey, though far from over, reminds us that exploration is a never-ending pursuit. Voyager may have reached the edge of the solar system, but our journey, both in the vastness of space and in the pursuit of knowledge, has only just begun. So, as Voyager sails ever further into the depths of space, carrying the hopes and dreams of humanity, we stand on the precipice of a new era in space exploration. We don't know what the future holds, but we do know that Voyager's legacy will continue to shape our understanding of the universe for generations to come. And for that, we can only be grateful. The journey that began with a simple mission to study the outer planets has now become something far greater, a testament to the power of human curiosity and the endless possibilities that lie ahead in the cosmos. If you've been captivated by Voyager's journey and the mysteries it continues to uncover, don't forget to like, subscribe, and hit the notification bell so you can stay updated on the latest space discoveries. Join us on this cosmic adventure as we explore more of the universe's most fascinating secrets. Leave your thoughts in the comments below. What do you think we'll discover next, and how will Voyager continue to shape our understanding of the stars? Until next time, keep looking up and keep exploring the unknown with us at NexuSpace.